Welcome back, everybody.
Hi, everybody. We're ready for lesson 2.9. If you'll remember, we skipped 2.8.
We did it in chapter P.
Yep, we did it in chapter P, so there's no need to do it again. We
No.
hope. Okay, so 2.9 is the last lesson for chapter 2B. Okay, so you'll remember in lesson 2.3, we graphed some polynomials. Remember that? They looked and they were factored form. You're just smiling and nodding. And we did that with zeros, multiplicities, and in behavior. So this should be review.
So we found the zeros. They were 2,
Yep.
-3, and 5. And if you look at the graph, you can see those.
Ta-da, there they are.
Then we talked about the multiplicities, and the -2 had, or the +2 had a multiplicity of 2, so it bounced. We talked about the in behavior. This is like x to the fourth, that thing. So we
Okay.
had this graph.
We did. So all we were doing at that time was creating a graph.
Pictures.
But a lot of times we only care about whether things are positive, negative, or zero.
That's all we care about.
So to solve some inequality where we have a function greater than 0, what does that mean, Mr. Lucky?
Well, when we take a look at that graph, it means that we're going to find intervals on the x-axis that make the y values positive, or the function values positive, which means that where are these values on our graph? They're above the x-axis.
Yes, they are. Is that what you're trying
Yes.
to spit out? Okay, and what does this one mean? F of x is less than 0.
That means we want to be below the x-axis if we have a graph. You
Basically,
have
we
to put
do.
the marker
I
down.
got it.
Okay. So, below the x-axis make it negative. Above the x-axis makes the function positive.
Right, and the key here is that we are looking for answers that are intervals of x. Okay? So even though we're looking where y is above and below, our answers will always be intervals of x values. So using that same picture we just had a minute ago, okay, and we took off the y values not to confuse you because we only care about what?
X.
X! Okay, we're going to find the values of x so that that polynomial function is greater than 0.
And what we're going to do in the next 4 problems is show you the very subtle differences between being greater than 0, less than 0, greater than or equal to 0, or less than or equal to 0. And
Correct.
once you get the hang of this, it should not cause you any difficulties whatsoever. But
Not so
we
much.
want to show you the subtle differences of all 4 symbols.
Okay, so positive would mean we need to be above the x-axis. So that would be this over here. So
Yep.
what intervals are going to make us be above?
Well, that's from
The
negative
x-axis.
infinity to that first 0 at -3.
Yep.
But because we're greater than 0, we're not going to include -3.
Okay.
And then we are above 0 from 5 all the way to infinity. And we do not include 5 because we don't get to equal 0.
We don't. Okay, so that kind of helps us give us a hint here for letter B. What's the only difference between the answer for letter A and the answer for letter B?
Well, we want to be greater than or equal to 0, which means everywhere we hit 0, we get to include those points.
Correct.
So we have the same intervals because we're still positive, but we're going to include -3 and -5. And we're going to go one more step here as well because there's actually, this is one of those where
Oh, I
it
forgot
shows
that
up
one.
every once in a while. It's kind of one of those annoying little details.
It is,
but
and I just forgot about it because I wasn't looking at the picture.
It is a detail. This function actually equaled 0 at x equals 2, but not to the left and not to the right.
So we have to include that one little dot.
Yeah, and there's a couple ways we could write this. We could just write an interval that's closed from 2 to 2. That just means it only includes 2.
Okay.
Okay, and the other
One way.
option is to just put a little set bracket and just say it includes the single point 2. There's no interval on the x-axis. It's just simply the point 2. So it's up to you how you want to write it. We'll take either one.
We will.
Just
Okay.
so you recognize it.
So this is a review of polynomials, how the graph fits with the inequalities. Okay? Now we're going to move into a new skill. Oh,
Nope,
sorry,
we're
we're
gonna finish
still
this
going less than, equal than. Okay, I'm ready.
So less than 0 means that we are below the x-axis,
We are.
which is there. And then she stopped drawing at 2 because at 2, remember, it hit 0, but we're not including it. We're not equal to 0 here. So we're going to go from -3
Okay.
all the way to positive 2, but we're not including 2. And then we're going to pick up at 2 on the other side, and we're going to go all the way to 5. But again, we did not include 2.
Okay.
Okay? Now, if we're going to be less than or equal to 0, we get to include the 2, which means we don't have to stop at 2 and start again. We just get to go straight from -3 all the way to 5, and we get to include each endpoint.
Okay.
Okay? And we're
So
doing
that
this all from the picture.
interval notation is very, very important, and the subtle differences between parentheses and brackets. Okay.
All right.
So what if we don't want to use the picture?
Well, if we don't want to use a picture, we can do what's called a sign chart.
We can.
We can. And we're going to show you how to make this sign chart when everything's factored, and that's pretty much what we're going to stick with.
Yep.
We're going to stick with things that are either factored already for you or are factorable using your factoring skills you have developed over the last few lessons, okay?
Okay, so let me show you how to make the sign chart, and then you can show them why it works.
Okay.
Okay, so we're going to take each factor, but when we do a sign chart, we have to have linear factors, which means I can't look at x minus 1 with a multiplicity of 2. I have to look at that, meaning x minus 1 times x minus 1.
So if it's squared, you're going to write it twice. If it's cubed, you're going to write it 3 times. You're actually going to write every single factor.
Okay, so I see 4 factors.
Which means we're going to have, next thing we're going to do is find the zeros. All right, so these are the numbers on the x-axis where each linear factor would be 0. So for the first one is x equals 1, the second one x equals 7, and the third one is negative 5/3. And what we're going to do is put them in order from
It's like
left
a
to
little
right.
number line.
Yeah, a little number line. They don't have to be equally spaced.
Nope.
We just want them spaced apart somehow. And all we need is to make sure we have them from left to right, smallest to largest. Okay? Don't put 7 on the other side of negative 5/3. It screws the whole thing up.
It messes you up. Okay, so the way I first learned sign charts is I just kind of guessed and checked some numbers. And I said, you know, if I'm looking at negative 5/3, I could pick a number to the right of it, like, I don't know, 0. And I could plug it into this linear factor, and I would go, well, that's positive. So what we're going to do is we're going to let a solid line be positive values.
Solid line positive.
And we're going to let a dashed line be negative. So if I picked anything to the left of negative 5/3 and I plugged it into that factor, that would be negative.
But only that factor.
But only that factor. Okay? So again, keep in mind, this means solid.
Positive.
Thank you. Well, that is solid.
Yes, it is.
Ah! Is it Friday yet? And this
Actually, it almost is.
equals negative. Is that better?
Yes.
Okay, so next factor, x is 7. Now, if we start to think about a line, x equals negative 7, I told him you were going to explain this
Okay,
part.
you want me to show them how this, why this works?
Show them why that.
Okay, so here's the deal. Basically what we're doing is looking at each factor as a linear factor. And if I asked you to graph y equals x minus 7, in Algebra 1 you learned you started at negative 7 and you had a slope that went up 1 and over 1. Yeah, no big deal.
Right.
The x value that actually makes this 0, aka the x-intercept, turned out to be 7 as positive 7, which is the number that we have on our sign chart.
Correct.
And if you look at just this linear factor, to the right side of 7, the y values are above the x-axis.
Or positive.
Or the y values are positive. And to the left of left of 7, the y values are below the x-axis, and the y values are negative down here. So what we're saying is when we're on the right side of 7, we're positive, and on the left side of 7, we're negative, because the line is going up.
So basically the way I was doing it, where you're plugging and chugging numbers, that works, but you can just visualize this line, and then you don't have to remember all those rules. So to the right is positive, and to the left was negative.
Okay. And the same thing's going to then happen for x minus 1. To the right of 1, the line would be above the x-axis, and to the left of 1, it will be below. And so what we end up with is we end up with 4 factors, and we're just multiplying them all together. That's what this thing right here means. It means multiply x minus 1 times x minus 1 times x minus 7 times 3x plus 5, and you're going to multiply them all. So what we have based on the sign chart, though, is a nice simple way to represent that. We have an interval to the left of negative 5/3. We have an interval between negative 5/3 and 1. We have an interval between 1 and 7, and an interval from 7 to infinity. And all we need to do now is look at the signs of each factor in each interval.
Multiply them, right?
When we multiply them all together.
Okay, so as we're looking at this, over here I have dash, 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 dash. So I have 4 negatives being multiplied together.
And a negative times a negative times a negative times a negative is a?
Positive.
So we're going to write POS, positive, okay?
In the middle, I've got a negative times a negative times a negative times a positive, so
That's negative.
that's a negative, okay? And think of this number line now as like a total, okay? We've got a positive, positive, a negative.
Positive makes a negative.
And
And then we
then-
have 4 positives all multiplied make a positive.
Great.
And going one more step here just for fun, these numbers here on the x-axis we're actually making the entire function 0.
Correct.
So these things are actually going to be 0 here, here, and here.
Those are your x-intercepts, which
Those are
we've
your
been spending a
x-intercepts.
ton of time on. Okay? All right, so now how is this going to apply to inequalities? Well, we've already kind of copied this sign chart over here for you, and now we're looking at a specific question. Instead of just saying make a sign chart, the question says solve.
One thing I forgot here real quick. This would have been positive,
Oh.
negative, negative, Positive. Okay.
We're going to solve the inequality. So basically, when is this function greater than 0? But what does greater than 0 mean?
Greater than 0 means positive.
So if I want to know when am I positive, where's our highlighter? Make it go.
Make it go. I'm making it go. Positive.
Positive.
Greater than 0 are here and here only.
Right. We cannot equal 0, so we cannot equal the values on the x-axis.
Right.
So,
If there's no equal 0, they're never going to use those numbers on
yep,
the
always
x-axis.
parentheses.
So how do we describe this first interval?
Well, we would go from negative infinity to negative 5/3. And then we would union that with 7 to infinity.
And understand that is because this interval here is this one right here.
Yep.
And this interval over here is this interval right here.
And that's it.
We're done.
Okay. So
Once
but
you have
that
the
was,
sign chart, it's pretty easy.
it's very easy once you have the sign chart. So that was for a polynomial.
But we just got done dealing with what kind of functions?
Rational.
Rational functions.
Which was a polynomial over a polynomial. So a couple of things to really remember here. When does a fraction equal 0? When the top is 0.
Top
but what
0.
else can weird happen on fractions?
Well, you can't divide by 0.
You can't. So they are undefined when the denominator is 0.
And it's very, very important that you understand the difference between equaling 0 and being undefined because it depends on which one we're dealing with.
Correct. So not only are we going to have to include our zeros from our factors, but we're going to have to deal with the factors of the top and the bottom.
And remember, here's the deal, just for fun. When it's greater than or equal to 0 or less than or equal to 0, this means equals 0,
Correct?
and that's going to occur when the numerator is 0.
Correct.
We will never, ever, ever use the points on the on our sign chart at places where the function's undefined.
Correct.
They don't exist there. So
They don't. They're not in the domain.
It won't, whether it's greater than 0, less than 0, greater than or equal to, less than or equal to, we're not going to use them because they don't even exist in the domain.
Correct. All right, so let's give it a try here. We're going to make a sign chart. We've got our rational function, and when I see three factors, I see 3x plus 1, and I see x minus 1, and I see x plus 3.
And the reason this works even with division is because the rules for multiplying and dividing positive and negative numbers are the same.
Yep.
Whether you're multiplying or dividing, as long as you're just doing all of it at once, doesn't matter.
Okay. So on our x-axis now, we have zeros of negative 1/3, positive 1, and negative 3. And again, Mr. Lecky paused for a second because he was putting them in order.
And I'm not smart enough to do all that in my head. Okay. All right, so these are all positive linear factors or increasing linear factors or lines that are going up. So
They are.
we are positive to the right of negative 3, negative to the left.
Okay?
Positive to the right of 1,
Negative to the left.
negative to the left. Positive to the right of negative 1/3, negative to the left.
Okay.
We'll
Now,
do this in class, but if any of those factors happen to have a negative x in front of it,
right.
the line for that factor would be going down,
It would.
and the dotted and solid part would be reversed.
Backwards. Okay.
So-
Now, the other thing we want to add onto this sign chart is we want to think about which values are zeros and which values are undefined. So when we look at the factor that created the negative 3, okay, that factor was in the denominator. So that is basically an asymptote, and we're going to have an undefined value at negative 3. Cannot include it ever, no matter what the question says. Okay? When we look at the negative 1/3, that came from the top. So that is actually a 0, and we're just going to put a little 0 above it so we know that's a 0, and we're allowed to equal a 0 if the question says so. And then if we have a value of 1, that also came from the bottom, so that is another undefined value. Okay? So our sign chart's getting a little busy, but it's really important to put that undefined 0 and undefined there. Okay, negative, negative, negative.
Negative here.
Yep. Negative, negative, positive.
Positive here. Negative here. Positive here.
Okay, so we have now created our sign chart, including the top and the bottom, and zeros and undefines.
It really will be helpful if you label it this way, because
Absolutely.
I realize this takes a little bit of time, a little bit of
does.
energy, but once you have this in front of you, it's
Just a matter of
so
reading it.
easy to answer the
Right,
question now.
Right. And we know, because we've tried this. We've spent like the last 3 or 4 years developing what's the best way to teach this. And this is really it. This is the best, as good
Is
as
that
it
all it
gets.
took us?
Yeah.
Okay. So
Okay.
here's a picture of our sign chart without all the lines and dashed and things.
Right.
This is just the
With
end
the
result.
summary.
Makes it a little easier to read.
Okay.
I'm going to pull out the highlighter.
Great. So the first question, letter A, asks for greater than 0.
That's less than.
Thank you. Less than 0. Less than 0 is another way of saying negative.
Negatives.
So we're going to highlight the negative pieces. But notice we're not going to equal anything.
Nothing else is highlighted.
Okay, so we're ready to write our inequality, which would be from negative infinity to negative 3. And from negative 1/3 to 1.
All
Nothing's
we're doing
included.
is describing these intervals that are highlighted.
That's it.
Piece of
Okay,
cake.
letter B.
All right, let's start over and erase all these markings on our number line.
Okay, so now we want less than or equal to 0.
Okay, so I'll go with the less than parts, the same as what we had before.
It is, but now I can also equal 0. There's only one extra value I can equal, and that's the negative 1/3.
So here we're looking for negatives or zeros.
Zeros.
Both of them are included.
Okay, so we're going to start at negative infinity again. We're going to go to negative 3, but we still can't include the negative 3 because that's undefined. And then we're going to go from a negative 1/3, but we get to include that because that makes a 0, and go to a 1.
But not including the
But
one.
not include the 1.
Notice the only number that changed between this answer and this one was the negative 1/3 because it was the only x value where the entire fraction would make a 0.
Equal 0.
The other two are still undefined and therefore never, ever, 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 ever included.
Okay, fast forward. We've got a couple more examples here. We recopied our sign chart over. And this one is now asking for greater than 0. I got a little carried away before, which is positive. So we're going to highlight our positive areas, but we're not going to highlight anything on our x-axis there. And so we're going to go from negative 3 to negative 1/3, and from 1 to 0, to infinity. What am I saying? That's what I'm saying.
That thing.
Okay. And again, letter D, we want to know where are we greater than or equal to 0. So the only thing that changed now is I'm allowed to equal anything that equals 0. I'm going to include that negative 1/3 value again. So I'm going to go from negative 3 with a parenthesis to negative 1/3 with a bracket, and then I'm going to union from 1 to infinity both parentheses. That's it. Alrighty? Okay.
Piece of cake.
Now, all this works and is well, fine, and dandy as long as we have one fraction.
What fraction?
One fraction.
We have to have one term, one thing to be positive or negative.
Correct. But what if we don't have that?
We need to fix that.
Okay.
What is that? How many terms or how many fractions do we have over here?
Well, I see 2.
2.
And I see not common denominators in those 2.
Well,
Which
other than
means-
crying, what's our next option?
Well, we have to add fractions together. So
Which-
we're going to need a common denominator.
Now, remember, in chapter P, we tried to eliminate all the fractions because it was equal to 0 or equal to something else. The problem with doing that here is that those denominators contribute to whether there are positive or negative signs in my inequality.
Yeah.
I can't get rid of them. I got to keep them. So I'm going to multiply the top and bottom of the first fraction by x plus 3. I'm going to multiply the top and bottom of the second fraction by x minus 1 so that I have a common denominator of x plus 3 times x minus 1. And it's still less than or equal to 0 because I haven't touched the other side. I'm not messing with it. So
Correct.
all we have to do now is clean up the top half here.
Okay, so this is going to be x plus 3, and this is going to be 2x minus 2.
That's going to be 3x, and then a plus 3 to minus 2 make a plus 1.
Yep.
And then over x minus 1 times x plus 3. I've seen this problem rather recently.
It looks a little vaguely familiar.
It kind of looks like the one we just did, which
It
was
is.
kind of on purpose. But
It was exactly on purpose because the
We
only
know.
thing that's new in this example is that we have to get it into one fraction first.
Yeah. Once you get into one fraction, go back a screen or two.
Make your sign chart, write your inequalities.
And
That's
I
it.
think, what was the actual answers just for fun? Because I can't leave it alone.
I can leave it alone.
I can't leave it alone.
You
I
can't
can't
find
make
the
the board
answer.
go backwards either. It's right here.
There it is.
There's my answer. I just had to do that.
Alrighty,
That'll do it.
that'll do it.